French fries. A fast food chain advertises that the medium-sized serving of French fries weighs 135 grams. A reporter took a random sample of 10 medium orders of French fries and weighed each order. The weights in grams were 111, 124, 125, 156, 127, 134, 135, 136, 139, and 141. Source: SoraNews24.com. Assume the population distribution is normal. Test the hypothesis that the medium servings have a meat population mean different from 135 grams. Use a significance level of 0.05. We'll begin by writing our null and alternative hypotheses. So our null hypothesis is that the population mean is the same as 135 grams. And our alternative is that the population mean is different from or not equal to 135. To do this problem, we're going to be using a one-sample t-test. We're already told that our population distribution is normal. And so we next need to find our test statistic and our p-value. And normally we find the test statistic and p-value using technology. So I'll demonstrate how to do this using StatCrunch. So the data for the weights of the French fries have been entered into our first column. And so to do our hypothesis test, we'll come here to Stat, T-stats because we're doing a t-test, and we have one sample with data. Our data is in column 1 under variable 1. And for our hypothesis test, we're testing whether the mean is equal to 135 or whether the alternative, the mean is not equal to 135. And we'll compute. And so StatCrunch now will produce for us the test statistic and the p-value. So here we can see a test statistic of negative 0.578 and a p-value of 0.578. So we have our test statistic of negative 0.58 and our p-value of 0.578. If we compare our p-value with our significance level, we see that our p-value is greater than our significance level, so we do not reject the null hypothesis. We cannot conclude the population mean is different from 135 grams. Construct a 95% confidence interval for the population mean. How does your confidence interval support your conclusion in Part A? Do you think the consumers are being misled about the serving size? Explain. Again, we will use StatCrunch to construct the confidence interval. So again, we have our data in column 1. And to construct the confidence interval, we come to Stat, T-stats, one sample with data. We select our column, which is variable 1, but this time instead of doing a hypothesis test, we'd like to do a confidence interval. And in this box, we make sure that the level is what we want. So again, in this problem, we'd like a 95% confidence interval. So we have 0.095 entered for our confidence level, and we'll click Compute. And so StatCrunch then produces the confidence interval for us. The confidence interval goes from 124.18 to 141.43. So again, our confidence interval, if we round it off to one decimal point, is 124.2 to 141.1. This is the range of values which we believe contains the true population mean, and notice that 135 is contained within this interval. This is how the interval supports our conclusion. In our hypothesis test, we concluded that it was possible that the population mean was 135, and we see 135 contained in our confidence interval. Since 135 is contained in our confidence interval, the consumers are not being misled. And the reason they are not being misled is because they expect the French fries to contain 135 grams, and our confidence interval tells us that it is possible that this is the true population mean.